These are your integrated Math 2 notes, Module 4, Topic 1, Lesson 5 notes. There's only one video for this section, and this is the last video for topic number 1. Our learning targets on this video are: 1, I can use the quadratic formula to solve quadratic equations or find the roots. And 2, I can use the discriminant to quickly determine the type of solutions for the quadratic equation. All right, so first thing you need to have down is the quadratic formula. You need to memorize this. Quadratic formula works for all quadratic equations, no matter what, as long as the form is in standard form. Okay, so it has to be ax squared plus bx plus c equals 0. So any quadratic equation in standard form, in this format, equal to 0, we can use this formula, which is x equals opposite of b plus minus square root b squared minus 4ac all over 2a. So a couple things here. This is opposite of b, so that's the negative b. So if b is 7, it will become negative 7. If b was negative 7, it becomes positive 7. That's going to change the sign. Plus and minus means there's two solutions, right? It's going to be this value plus whatever's over here divided by this. It's going to be this value minus whatever this turns out to be divided by this. Okay? And then in here, b squared, straightforward, minus, that's a subtraction sign. That is positive 4 times the a value times the c value. So we'll talk more about this, but this is a subtraction sign. B squared minus positive 4 times a times c. And it's all over 2a. So do what you need to do. You need to memorize that formula. Oh, you need to pause the video. If you don't have this all down yet, pause the video. Let me give you an example now. All right. Example is going to be, we're going to solve x squared minus 3x equals 24. So your first thing is in standard form? Not quite, right? It has to be equal to 0. So the first thing we need to do on this one is we're going to subtract 24 from both sides. All right, so then we get x squared minus 3x minus 24 equals 0. All right, so now we can do our ABCs. All right, so on our example here, A equals 1. Some of you get confused with this in class. Okay, there's no number in front of the x squared. That means that number is actually 1. So it's 1x squared, so A value is 1. All right, our B value is the coefficient of x, so it's negative 3. So the minus 3, that's our B value. And then our C value is just the constant or the number. In that case, it is the negative 24. All right. So now we have our ABCs. Our next step is we simply substitute these values into the formula. So we take that negative 3, boop, to negative 3, boop. We're going to take the 1, boop. We're going to take the negative 24, boop. We're going to take the 1 again, boop. And when we substitute it in, we write this down. I want to make sure you put in parentheses around the value you're plugging in for your variables. Okay? So let's do it. This is very critical that you do it this way. Okay, so we're going to go x equals opposite, parentheses, b, negative 3, plus minus square root. I'm going to plug in again, negative 3, substitute negative 3, squared, that's b squared. Subtraction sign, minus, positive 4, multiplied by a is 1. Multiplied by c, which is negative 24. And this is all over 2 times a, which is the 1. Okay? So you don't do any simplification in the beginning. You just show exactly what you substitute in. It helps me find mistakes. Sometimes I can see your mistakes if you show me all your work here. Okay? All right. Now we start the simplification process. We got to follow the order of operations. So we got to do the entire top simplified before we can divide from the bottom. Okay, so we can simplify the bottom, simplify the top, then we can do the division. And then within the order of operations, we have the square root, that's like a grouping symbol, so we got to follow the order of operations in here. All right, so let's do it. We're going to go x equals, I'll go ahead and multiply -1 times -3, or take the opposite of that. I'm going to get 3 plus minus square root. -3 squared is 9. Okay, this is a subtraction sign. All right, so if it helps you, you may want to just put parentheses around the 4 as well. That's usually not written that way in a formula, but you can do so. So you know that subtraction sign, +4. So we're going to go 4 times 1 times -24. That gives me -96. So it's going to be minus -96 all over 2 times 1, which is 2. Now we know our integers, subtracting a negative, we change that to add the opposite, so it becomes plus a +96. Okay? That's one way of doing it. I'll show you another way real quick how people handle this. Some people prefer to go ahead and say, instead of subtraction, they change the formula to add the opposite, and they go, let's make this a plus sign, and they make that -4. Okay? So then you're going -4 times 1, you get 4. -4 I should say, and then -4 times -24 is how you get the +96. So either way works. Do what works best for you. All right, so now we're going to simplify further. We're going to get x equals 3 plus minus square root of, what's that, 105? All over 2. All right, now we got to ask ourselves, it's going to want you to simplify the square root, if you can simplify as a simplified root. So are any perfect squares go into 105? So 4, no. 9, no. 10's not 10, 9, 16, 25, 36, 49, 64, 81, no. So this is simplified right now. So we would be done. X equals 3 plus or minus the square root of 105 all over 2. All right, we're done. Now I could write this another way. You could also write this as x equals 3 over 2 plus or minus the square root of 105 also over 2. Okay, you could write it that way, but either way works for me. All right, sometimes you want the decimal number. So if you want the decimal number, I'm going to continue from there. I'm going to go, what's the 105 square root is about 10 point, I don't know, 100 is 10, 121 is 11. So I'm going to say maybe, I don't know, 10.2. So we're going to go x equals 3 plus minus 10.2 divided by 2. So then I get x equals 3 plus 10.2, which was that 13.2 divided by 2. And x would also equal 3 minus 10.2, which is what, -7.2? -7.2 over 2. And that would become, I think that's 6.6. And this would become -3.6. So you'd have x equals 6.6 and x equals -3.6. That is your solution, approximate solution with the decimals. Okay? So that's the quadratic formula. Just takes time and practice. Your key to success in the beginning is just making sure you determine the correct A, B, C values and you substitute it into the formula the proper way. That's half this battle, and then we got to be real careful with our simplification process. Okay? One other thing I want to talk about with the quadratic formula is the idea of the discriminant. The discriminant is just the part of the formula that's underneath the radical sign. So it's the b squared minus 4ac. And here's a quick little trick you can use, especially those of you that want to go to four-year college. You're going to be taking the ACT and the SAT test. They usually have a question or two. We'll ask you something about what type of zeros, what type of roots, or what type of solutions does this quadratic have? And what you can do, instead of solving it and spend all that time to solve it, you can just look at the discriminant and find the value of the discriminant. So our example is here. We have 3x squared plus 5x plus 1 equals 0. Here's our ABCs. All we need to do is plug in to b squared minus 4ac and get that number. So we plug it in to substitute the values for b, a, and c. And we get 25 minus 12. So we end up getting 13. All right. What does that 13 tell us? Well, think about it. That's the 13 is the number under the radical. So if the number under the radicals is a positive number, well, you're going to have a number here for b plus and minus this number divided by this. So you're going to have two solutions. So we'll have two real solutions if the discriminant is a number bigger than 0. Okay, so it's a positive number. B squared minus 4ac is a positive number. We have two solutions. If it comes out to be 0 inside here, so the discriminant is 0, then you're going to have one real solution. Okay, that makes sense. Think about it. If this is 0, square root of 0 is 0, so you have something for b, say 10. Well, actually, in this case, it would be 5. This isn't the right one, but let's say it's 5, right? Plus or minus 0. Well, that's just 5. Then you divide by numbers, it'll be one solution. All right? Then, if the discriminant is a negative number, think about it. We'd have a square root of a negative number. Square root of a negative number, we can't do that. Right? So there'd be no real solutions if it's a negative number. Okay? So, positive number, two solutions, real. If it's 0, one real solution. And if it's a negative number, we know there's no real solutions. Soon to be two imaginary solutions. All right? One more thing. Rational solution versus irrational solution. This number is 13. 13 is it's a positive number, but it's not a perfect square. So it's going to be an irrational solution. Our solutions will be irrational. If it's a perfect square number, 1, 4, 9, 16, 25, 36, or 0, then it's going to be a rational solution. Okay? So we'll talk more about these solutions next week, but rational solutions are any solution that can be written as a fraction. Irrational solutions are solutions that cannot be written as a fraction. So if you have a perfect square, it's going to come out to be a whole number that you can write as a fraction. All right, and we'll address this more. For now, all I want you to know is if this number is 0 or a perfect square, we're going to say it's a rational solution. If this number is just 1, 2, 3, 5, 6, 7, 8, 10, and so on, then it's going to be an irrational solution. Okay? And that's it for this section and for this topic.